Good morning. Today we will talk about circular motion, centripetal force, centrifugal force and its applications. So, first we will discuss what is circular motion. A circular motion is a type of motion in a circle at constant speed. When a body moves in a circle with constant speed, then it is called circular motion. If we want to specify it, we can say it is a uniform circular motion. So, like the motion of any planet around another planet, like motion of a earth around the sun is a type of circular motion. Now we will discuss the quantities which are used in the circular motion. First quantity is angular displacement. So, in the left figures, two figures A and B, they represent the circular motion of a body. So, R is the radius of the circle. The first body is at the horizontal line at point P. So, in position in figure B, so body moves an angle theta and it reaches the point P prime with by covering arc length L. So, according to that we will define its angle. Angle is arc upon radius. So, angle is theta, arc is L and radius is R. So, theta is L upon R. Theta is called angular displacement. So, if the body is at position theta 1 and then it moves up to angle theta 2, then the angular displacement delta theta is final angle minus initial angle. Final angle is theta 2 while the initial angle is theta 1. So, the angular displacement is defined as theta 2 minus theta 1, final angle minus initial angle. Next we define the term angular velocity. So, the average angular velocity is defined as total angular displacement divided by time, while the angular displacement is delta theta and time is delta t. So, omega bar, which is the symbol of average angular velocity, it is equal to delta theta upon delta t. And next term is corresponding to the similar term, it is instantaneous angular velocity. It is defined when time approaches to 0, delta t approaches to 0, then the omega bar becomes omega, that is instantaneous angular velocity. Next quantity, important quantity in the circular motion is angular acceleration. It is defined in the similar way as the linear motion. So, it is the rate of change of angular velocity with respect to time. So, omega 2 is final velocity, final angular velocity, omega 1 is initial angular velocity. So, omega 2 minus omega 1 upon delta t, this is called average angular acceleration. If we want to define instantaneous angular acceleration, then the only limit is delta t should approach to 0. So, rest terms are same except the delta t should approach to 0 for the instantaneous angular acceleration. Next, we come to the relation between the angular quantity, that is omega, and linear quantity velocity. We know in the linear motion we use the term velocity, acceleration, displacement, but if we talk about the circular motion, then the quantities used are angular displacement, angular velocity and angular acceleration. All these terms, they are interlinked by v is equal to r omega, where v is velocity, r is radius of the circle or the point at which body is located, and omega is angular velocity. If we want to find the relation between a and alpha, similar relation we can find A is equal to R alpha, where A is acceleration and alpha is angular acceleration. So, if we want to find the relation between the linear quantities and the angular quantities, then simply multiply angular quantity by R, then it is equal to the linear quantity, that is velocity is equal to R omega. So, next we come to some conclusion. So, the object which is further from the axis of rotation, that is O, they move faster because V is equal to R omega. So, if R is more, then velocity is more, if R is less, then velocity is less. So, here the two bodies A and B, the velocity at point B is more as compared to velocity at point A. Here one point we note that angular velocity is same, but the linear velocity is different because the body is moving in circular motion, and from one point to another its position is changing. So, position is changing means its direction is changing. So, velocity is changing with respect to time in the circular motion. So, velocity changes from VA to V prime A and BV to B prime B. So, this is correspondence between the linear and angular quantities. The displacement in linear motion, it is denoted by S, while the displacement in rotational motion or circular motion, it is denoted by delta theta. Velocity is change of displacement with respect to time. Similarly, angular velocity is change of angular displacement or angle with respect to time. Acceleration is rate of change of velocity with respect to time. Similarly, angular acceleration is rate of change of angular velocity with respect to time. So, now we come to the kinematical equations in two different type of motion, linear motion as well as the rotational motion. In linear motion, in the right side, we suppose A is constant, that is acceleration is constant. So, the V is equal to U plus AT, S is equal to U plus V upon half upon 2 into T, S is equal to UT plus half AT square, and V square is equal to U square plus 2S. These formulas you already know, but similar to these, on the left side we come to know about the rotational motion. Instead of A, here alpha is constant. So, instead of velocity, here comes the angular velocity omega. So, omega is equal to omega naught plus alpha t, theta is equal to half omega naught plus omega into t, and third equation similar to the linear motion is theta is equal to omega naught t plus half alpha t square, and fourth one is omega square is equal to omega naught square plus 2 alpha theta. So, I think now it is clear that there is same analogy between the linear motion and rotational motion, except the few terms like instead of velocity we will use angular velocity, instead of displacement we will use angular displacement, like these small terms. So, next we come to the uniform circular motion. Uniform circular motion is a type of motion in a circle of constant radius but at constant speed. So, instantaneous velocity, it is always always tangent to the circle, like we have shown here the direction of velocity, it is always tangent to the circle, to the radius of the circle. So, velocity at first point is V1, which is tangent to the circle, and similarly at V2. So, now we come to the term centripetal acceleration. This is important term. Same analogy we can define from Newton's second law. If we want to define Newton's second law in circular motion, then instead of acceleration we will come here the term comes is centripetal acceleration. So, in detail we will define an object moving in a circle at constant speed, it accelerates because its direction is continuously changing. So, how quickly an object changes direction, it depends upon its speed and radius of the circle. So, centripetal acceleration, it depends upon two things. First one is speed and second one is radius. And centripetal acceleration, it increases with speed but it decreases with radius if we want the radius to be get larger and larger. So, velocity centripetal acceleration is directly proportional to velocity but inversely proportional to radius. So, here I have written the expression for the centripetal acceleration as well as centripetal force. So, first we define according to Newton's second law, acceleration is directly proportional to force. Since acceleration and force they are directly related, so force also point towards the center. Here the important point is that force is vector quantity, so it is directional. So, its centripetal force, it is required for a body to move in a circle and it is always towards the radius, towards center along the radius. According to Newton's second law, F is equal to total sum of forces is equal to mass into acceleration, while the centripetal acceleration is v square upon r. We already discussed that if the velocity increases, then centripetal acceleration also increases, and if the radius increases, then centripetal acceleration decreases. So, total sum of forces is equal to m after substituting the value of AC v square upon r. So, the total force centripetal force is mv square upon r, where v is the velocity, r is the radius, m is the mass of the body, and Fc is the centripetal force which is acting always towards the center and along the radius. Now, we come to the non-uniform circular motion. So, we already discussed uniform circular motion in which body is moving with constant speed, but in non-uniform circular motion the body has varying speed, like different speed at different point. So, it has two components. First one is tangential force and second one is FR, radial force, which we call centripetal acceleration, centripetal force. So, there are two types of force. First one is tangential force and radial force. It is because this tangential force, it is because of non-uniform motion, and this force is because the body is moving in circular motion. So, in non-uniform circular motion, total force is the sum of tangential force and radial force. Similarly, if we define acceleration, it is sum of tangential acceleration and radial acceleration. So, for non-uniform circular motion, we need to consider two type of forces, tangential and radial. Tangential because its velocity is changing, radial because it is moving in circular motion. So, now we will define what is tangential and what is radial. A radial we already did, same as centripetal acceleration. So, first we define tangential. This is same, we did this expression, the relation between the linear quantity and angular quantity. A is equal to r alpha. A tangential acceleration is the acceleration in linear motion, r is a radius of this circle, and alpha is angular acceleration. So, tangential acceleration is r alpha, while the radial is same as the centripetal acceleration. So, a r is equal to v square upon r, where v is r omega. So, after substituting v is equal to r omega, it becomes r square omega square upon r. After cancelling out one r, it becomes omega square r. So, radial force, a radial acceleration, or we can call centripetal acceleration, it is equal to omega square r, and tangential is alpha r. If body is moving with constant acceleration, that is alpha is 0, then tangential acceleration is 0. If body is moving, if body is having non-uniform circular motion, then alpha is non-zero, so tangential acceleration is non-zero. So, this term tangential acceleration we will define for non-uniform circular motion. So, next we will define, we can say that I will conclude here what is radial force and tangential force like. So, if a body is having non-uniform circular motion, then there are two type of forces acting upon a body. First one is tangential and second one is radial along the radius and towards center. Then the total force is the sum of these two forces like tangential and radial. Next we come to the what is linear motion, rotational motion and rolling motion. So, linear motion is a type of motion which is along a line. It is not moving, like it is not circling, it is only moving in forward direction. In rotational motion, it is like rotating around a axis and along the same radius r. In rolling motion, it includes linear motion as well as rotational motion, that is body is moving towards forward direction and as well as it is rotating. So, rolling is the combination of, this is the combination of linear motion and rotational motion, like we can take the example of bicycle. So, it is moving in forward direction as well as it is having rotational motion. So, now we will discuss the difference between tangential and centripetal. We already know tangential follows the guideline of linear quantity, but centripetal is the term associated with circular motion, and tangential speed is the instantaneous linear speed of an object travelling in a circle. But the centripetal force or centripetal acceleration, it is always towards center. Center seeking means it is always towards center. And the third term we will now discuss, centrifugal force. It is opposite to the centripetal force. It is center fleeing. Fleeing means opposite to the center, away from center. And tangential acceleration, it is the instantaneous linear acceleration of an object travelling in a circle. So, the centripetal force, object in motion tend to remain in motion at the same speed and in the same direction unless it is acted on by an outside force. According to Newton's first law, that only a force can cause a body to move out of a straight linear path. In circular motion, we know direction of a body is changing at every point, at every time. So, we need a force to be acting upon a body to change its direction. So, this force is called centripetal force. So, centripetal means it is acted towards the center. since it acts towards the circle, towards the center of the circle of the circular path. All circular motion requires a centripetal force, otherwise body continues to move in a straight linear path. You already know, if body is moving in a linear path, if we don't apply any force, then it is, according to Newton's first law, it continues to move in the same path. But if we apply some force on a body, then its direction changes. So this force is called centripetal force. Centripetal acceleration, this is the direction of centripetal acceleration, and this is the tangential velocity or tangential acceleration. So it is always towards the center. We already did this expression, centripetal acceleration is v square upon r, where v is the velocity of this particle which is moving in this circle, and r is the radius of this circle. And according to already you did this, velocity is omega r and omega is 2 pi upon t. So after substituting all these values, we will come to know centripetal acceleration is 4 pi square r upon t square, where 4 is constant, pi is 22/7, r is a radius of this circle, and t is time period. Time period means to complete one circle, how much it will take time. So this is time period. So I will repeat here. AC is v square upon r. This is centripetal acceleration. V is velocity of the particle at any instant. R is a radius of this circle. If we substitute the value of V, then we will come to know AC is equal to 4 pi square r upon t square, where 4 and pi they are constant, r is radius and t is time period. So the centripetal force expression becomes Fc is equal to mac, mass into acceleration v square upon r, v is equal to r omega, so m r omega square. This is very important expression for the centripetal force. Fc is equal to m r omega square. M is mass, r is radius of the circle and omega is angular velocity. So centripetal force is m r omega square, and its direction is always towards the center. Now we will come to know about the work done by the centripetal force. We know the direction of centripetal force is towards the center of the circle and along the radius, while the velocity direction is always tangent to the circle. So the angle between these two vectors, it is 90. It is 90. So work done is 0 because it is Fs cos theta. Theta is 90, cos 90 is 0. So work done is 0 for the centripetal force. So now we will conclude. Centripetal acceleration, it depends upon two factors, speed and the radius. So more acceleration is required for high speed turn and more acceleration is required for tight turn, that is small radius of curvature. Now if a body is moving like this with bigger radius, then centripetal acceleration is less here as compared to this case, because r is less then acceleration is more. If r is more then acceleration is less. AC is equal to v square upon r. Now we will solve some numerical related to the portion we already discussed. A Ferris wheel with a diameter 18 meter, so its diameter is 18. So radius is half of the diameter 9 meter. It rotates 4 times in a minute. 4 times in a minute. Calculate the velocity of the Ferris wheel. First we need to calculate the velocity, and second term, Calculate the centripetal acceleration of the Ferris wheel at a point along the outside and calculate the centripetal force. A 40 kg child experience. First we need to calculate the velocity. So velocity Vc is equal to 2 pi r upon t. So 2 pi is constant and r is 9. Its radius is 9 and time period is 15 because it is covering 4 times in a minute. So in 60 seconds it is covering 4 rotations. So for one rotation it is 60 by 4, it becomes 15. So velocity is 2 into pi into r upon time period t. While the second thing is centripetal acceleration. Centripetal acceleration is v square upon r. V we already calculate 3.77. So acceleration is 3.77 square upon 9. So it becomes 1.58. Third term is Fc, centripetal force. It is mv square upon r. V square upon r is acceleration. So m is mass 40 into 1.58. It becomes 63.17 Newton. Next, the second example. What is the effect of radius on centripetal acceleration? A bobsled track contains turns of radius 33 meter and 24 meter. So body is moving with velocity 34 meter per second along the two radius. First one is 33 meter and second radius is 24 meter. So we need to define the centripetal acceleration for each turn and express answers in the multiple of g, that is 9.8. So in the first, centripetal acceleration is v square upon r. V is 34. Here the body is moving with same speed while the radius for the first circle is 33. So AC is 35 meter per second square and in second case AC is 34, its velocity upon radius is 24. So 34 square upon 24, it is 48 meter per second square. But we need to define this in terms of g. So after dividing this by 9.8, it becomes 3.6 into g. Similarly for this 4.9 g. So next we come to know the effect of speed on the centripetal force. Here a mass of 0.9 kg, it moves at a constant speed on a circle that is parallel to the ground. We have given that tension is 17. Find the tension in 17 meter guideline for a speed of 19 meter per second. This is very simple. So force is equal to tension here. So this force, centripetal force, it is equal to the tension. It is equal to mv square upon r. Mass is 0.9, velocity is 19 and radius is 17 meter. So after calculating all these things, tension is equal to 19 Newton, which is equal to the centripetal force. Centripetal force, it is not different type of force. It is already we know, like instead of friction centripetal force comes gravity, normal and tension. It is not a different type of forces. It is a new role for the same force, like we did example now. So if a body is moving like in a circular motion, then its weight mg, it is always acting vertically downward, and normal reaction which is given by earth, it is in upward direction, and force, this force of friction, it is in this direction. So what is Fc? Fc is equal to this friction. So Fc is equal to this friction. Here FBD means free body diagram. FBD, free body diagram. So all the forces which is acting on a body here are shown here. Its weight vertically downward, normal reaction by earth N, and force of friction F. So, if the earth is rotating around the sun, then orbiting around the sun,